Welcome back, ladies and gentlemen. This is Mark Anderson for Keller Community College for our third video of a six-part series to talk about my Unit 4 test for statistics. And we are looking now at the end of our correlation unit, and we're going to talk specifically about the coefficient of determination, the standard error of the estimate, and also do some writing to explain what these concepts mean. Now, one thing I need to say, if you are memorizing the definitions, that's going to give you a big leg up on this test, because there are going to be a lot of questions that talk about the words instead of the symbols. For example, the coefficient of determination is one, that's a vocabulary word, and that's our r squared. The r, which is not to be confused with r squared, the r is called the correlation coefficient. So please make sure to not get those messed up. The correlation coefficient is r, and that is the percentage of signifies the strength between the independent and the dependent variable. But if you square this amount, so if you take our 0.75 and square it, you get 0.5625, or 5,625 ten-thousandths, or 56%. And what this coefficient of determination, this r squared, tells us, it tells us how much of the independent variable, or x, how much of the independent variable is responsible for the dependent variable's results. So the independent would be our x, and the dependent would be the y. So the format goes that our r squared gives us the percentage of how much the independent variable is responsible for the dependent variable's results. And I'm going to translate that in a sentence. And what that really means is how much percentage we can be sure of and this is definitely an oversimplification of it for this level of class, but it's going to kind of put things in perspective. We can be sure of, and how much is unknown. All right, so what this means is that we can format a sentence like this. 56% of the y's results, R-E-S-U-L-T-S, results, is affected by the amount of x's influence. And the complement of the 56% is 44%, and this is how much is unknown. So let me put this in context. Let's say that we found out that we changed the number of, let's say, ambulances on patrol. And we've upped the number of ambulances rolling around some city or town. We just upped the number of ones that would be around. And we noticed that there was since this is positive right here, so let's go with this. Since there was a 75% correlation to lives saved and number of ambulances. Now the independent variable, the one that we can change, is the number of ambulances. And then the dependent variable, which is the number of lives saved, would be that. Now again, I'm completely making this up, but I'm trying to show that there is a relationship between that 56% of the amount of lives saved is affected by the amount of the number of ambulances influence. So, I mean, yeah, just by having ambulances around won't save lives, but if you're looking at something that shows that, then sure. I mean, again, I've just completely made this up. But the standard error of the estimate, it kind of works in with this r and r squared, and the standard error of the estimate is a lowercase s. I use a cursive lowercase s because my lowercase s's look like 5s. And the standard error of the estimate is the standard deviation of the observed y values compared to the y prime values. Now, let's kind of remind ourselves what we're talking about with y and y prime. See, you have a line of best fit that tries to go through as many points as possible. It's definitely not going to be perfect. Now, the vertical distances between these dots and this y prime line, the line of best fit, creates this normal standard deviation that's going to give us our, quote, give or take away from this line. So this y prime line is going to give us a great way to predict the future based on how much x we get versus how much y is given by that amount of x. But there's going to be a field of possible, I would say, possibilities away from that line based on this standard error of the estimate. Now, what we're about to do is put all of this vocabulary and put all of this into play with the next problem. And I'm going to have to move this down here because this is going to be a linear regression t-test, always assume two-tail here, based on this information. Now, what I've done is I've kind of sped things up a little bit, where I actually have typed this already into the calculator. And to do so, you would go and click Stat to type your stats, and then you would hit Enter, and the Enter would then allow you to type this in. And you can see that I've already put my list 1 and list 2 in. My X, the number of employees, is my list 1. And this would be raising the number of employees and then looking at my revenue in terms of thousands of dollars. So what I'm going to do is move, since this data, you can type this in if you'd like, pause the video and do so. But since I want to actually kind of write in the bottom part here, I'm going to do this so I can see all of the rest of this worksheet here before I end the video. Now what I'm going to do is, looks like my friend's playing Dota 2. Awesome. So what I'm going to do is get this relevant info here, and by doing the shortcut, and the shortcut is to click Stat, move over to Tests, and then scroll down to option either E or F depending on your calculator, and this one happens to be E, the linear regression t-test. So, and again, newer calculators will have more options, but this is the one you want, the linear regression t-test. Hit Enter. Now, you want your X list to be list 1, list 2, the frequency should be 1. Highlight not equal to 0, just because this is a two-tailed test. It won't actually change what we're going to be looking at, but it's good practice. And then go down to Calculate and hit Enter one more time. Now, what this allows us is to look at all of the different parts of this problem, but scroll down a little bit because this actually gets into things that we're wanting to look at. We want to look at the A value, the B value, and this A and B match pretty well with what I was expecting. Now the R and the R squared, like, we can't see this all at once because of the height of the screen. So what I'm going to do is park it right here where I can see my AB, my S, which is my standard error of the estimate, and my R squared, and my R was right off the screen as 0.80. So let me freeze this screen, and now I can write on this all this important information. My A is going to be, or my start is negative 7.17. Now we're going to translate this y prime, and it's going to sound a little weird, but it'll make more sense when we get it written down. The B is 0.82. I'm rounding to 2 decimals here. My y prime line is negative 7.17 plus 0.82x. This is my line of best fit. My R value, or the correlation coefficient, is 80. So this is a pretty strong correlation right here. And my R squared, if I squared this, would be 0.64. Which means, well, again, we'll do the standard error, we'll do the coefficient of determination in just a moment. Now the S, the standard error of the estimate, is 5.98. And we can see that there rounded. Okay, and again, the R was right below this. The R was equal to 0.80. So if we could see that, that'd be awesome. So let's first of all start off by asking what this is asking, which is, what is the coefficient of determination telling you about this data? So there is your coefficient of determination. Well, this is saying that 64% of the dependent variable, in this case the revenue, 64% of the revenue is affected by the amount of employees. So it follows this format. 64% of the dependent variable is affected by the amount of the independent variable, and then the complement of the R squared, or in this case 36%, is unknown. So my robotic voice was the signal to kind of plug in whatever the problem is going to spit back out at you. 64% of the dependent variable, this is our y, and we could see that based on our table up above, is affected by the amount of the independent variable, or x. And our tables are always going to be given an x over y, so don't feel like no one's gonna pull a fast one on you there. So this is our format for the coefficient of determination. Now if we want to talk about the R, this would be a strong positive, again without looking at table I, I'm going to assume that this is strong positive, but this is going, and it may not be high enough to be called strong positive without table I just have to go on my gut here. But this right here is a strong positive correlation between the employees, the number of employees, and the revenue. Now I want to do the standard error of the estimate, and as a bonus I want to translate y prime. And I know it doesn't ask to translate y prime, but starting in the fall of 17, I'm going to be asking all of my students, or the fall of 16, I'm going to be asking all my students to do more translating of the y prime, so I want to throw that in here as well. Alright, so what does the standard error of the estimate tell you about the data? Well, what this says is our standard error of the estimate is this 5.98, but that is a measurement of how far off the y prime line you are. So if you're going to do this in a sentence, the units you're going to use is your units of y. So this means, this 5.98, which means that despite the fact that this is an 80% positive correlation, we are going to be anywhere up to 6,000 off the line. So it's a give or take. This is our normal distance away from the line. So what this means is that the the standard deviation of the observed y values will differ $6,000, since we're talking about money, away from the y prime line. So I mean, if you wanted this standard error of the estimate says that you can be off by $6,000 normally. The standard deviation means is that you will, 66% of the time, which is, a rough approximation of one standard deviation above and below the norm, will be $6,000 away from the y prime line, which, is probably based on its sample size and probably based on where these dots were on the line. So be aware that there are probably different ways to explain this. This is a very intro to stat way of talking about it, but I hope it helps out. And this is, again, been a video for me, and thank you for watching, and parts 4 through 6 are coming up.